Hey guys, just welcome. I'm going to be Dave Tanner for a minute. Just let you know we've got about 4 or 5 presentations today. If you've got questions, and I imagine you will, we'll hold them all to the end and we'll get all the presenters and the gurus up and they'll be able to answer any questions that you've got. So I just need to start off on behalf of KVH. Obviously Barry O'Neill's our new CEO, or Chief Executive, and he couldn't be here this week, so he will be here next time. So just a few KVH updates. I talked to you guys last time about some biosecurity guides. We've got some sort of pocket guides that look like photos of your ex-girlfriends, but much longer. And they'll be there. They'll be in the post-harvest for your guys to use. And also we do have posters and videos in multiple languages, so you can print those out and use for your workers. So I just want to start off by talking about some of the monitoring that we've done as KVH. We sort of sat down at the, in winter last year, Jane Chamberlain and myself sat down and said, what do we need to know if we're going to get a variety to grow in Te Puke from a monitoring perspective? Like obviously there's a whole lot of experiments, a lot of plant and food and R&D stuff going on. And we really want to know 4 things from a grower's perspective. We want to know that, firstly, we were looking at stumps there. We wanted to know, could we graft something on it? Would that graft take, or would those stumps be too infected? You remember back to the dark days of last winter, we didn't know any of that sort of stuff. So that was the first thing we wanted to know. And then, you know, if the graft took, would it survive, or would it just fall over after a month or 2? Then we wanted to know also, was there a commercialised variety, you know, essentially a PVR variety that we could graft as a replacement for Hort 16A that would take us into the future and hopefully survive under and thrive under PSA conditions. And the 4th thing that we wanted to know was, you know, if PSA arrived in a new variety block, so it wasn't already infected, it came along and it hit a new variety block, what would the speed of infection through that block be, and what sort of rate of progression would there be? So just to let you know how it all works, Jane Chamberlain, we split this up between some of the Zespri team and some of ourselves. So Jane Chamberlain and Will Max looked after the graft survivability part and the progression of the new infection through blocks. And KVH, with the help of Lathan Oates, monitored the commercialised varieties, so what was already out there and how was that looking. So I know some of you guys were asking about the green. I made the call to focus on the PVR varieties from the fact that if we cut off Hort 16A, we probably couldn't afford, if you're in like my position, you couldn't afford to put Hayward on there, you need to put something different on there. And also plant and food, Mike Manning and his team are doing some extensive progression monitoring through the Hayward anyway, so they'll pick up that part. So firstly we went through every vine in Te Puke that was G3, so 37,000 vines. And I want to point out that's every legal vine, because if you've got some hidden somewhere, we obviously didn't come. That was the last week's joke, but I thought it was quite good. So then we went through 37,000 vines, and some of you guys will have seen the pie chart of that. And then what we've done is we've cut that down, because we don't have the time to get through those regularly, and we've cut it down to 10 orchards. So we're picking different altitudes, different levels of infection, and we're going back to those every 3 weeks, and you guys will be able to see those after each monitoring round. You'll be able to see those up on the website, so you can get a picture is the disease continuing to get worse on those varieties, is it staying still, okay? So we also picked up the other Zespri varieties, the G14 and the G9, and we're doing the same with those, and also the non-Zespri varieties, the Y374, commonly known as Kiwi Kiss or Bostock, the Y356, which is Simon Dickey's variety, and as of today, the A19, the Turner's variety. So yeah, you'll see those results every 3 weeks up on the website, and providing we can get permission from those non-Zespri varieties, we will have those up there as well. And I guarantee you, if their blocks are looking good, they will want us to display their data. So. Just a little caveat around some of the other varieties, you know, the G14, the G9, those sort of varieties, we're monitoring about 7,500 vines regularly. The Y356 is 100 vines in Te Puke, so it's a smaller subset. The Y374 and the A19, we're only about halfway through monitoring, so we'll be able to give you a better steer once we've gone right through the whole lot of those. Okay, so I'll pass on to Lathan, and he will take you through the rest of this. Cheers, Lathan.
Cool. Thanks, Braden. What I want to do is just, what we've been doing is going through, this is just that initial graph. Last time it was on about 30,000 plants. We finished the last 7,000. 94.5% of all those vines didn't have any signs of secondary infection. So what we're looking at is shoot dieback, grading that as a 1 or 2 shoots, 2 to 5 or 5 or more shoots. And that's probably the main thing that we've done. And then if it gets into the cane, that's another score. The bigger group of what's infected is 1 or 2 shoots per vine, which is quite a good sign. If you go into the subset of that, which is that 10 or so orchards, 6,500 vines, it changes a bit. It's quite blurry. The uninfected vines changes to 93%, so that takes into consideration that initial subset we've taken out. So it starts off a little bit worse. It has progressed a little bit, so 91.3% is the uninfected vines on those now. So that's after 3 weeks. It's moved a little bit, and that's mainly in the 1 to 2 shoots, jumping from 5.2% to 6.9%. So a little bit of progression in there. Hasn't moved into the 2 to 5 shoots or the 5 or more. Or the canes, a couple of canes have been cut out, but not enough to make a difference on it. This is the G14. The PSA-wise, it's looking pretty good. The common theme from looking around is that the G14 has the least of the secondary infections. Does get some dieback, so mainly a shoot that'll die back and stop against the cane. Doesn't seem to progress. Haven't seen any canes really falling over from it. If you're ranking them at the moment, from my point of view, what I've just seen, you'd nearly say G14 out of the new varieties was the most PSA tolerant or resistant, whatever the right word is. Then the G3 and the G9 would slip in after that. With a G3, it tends that the infection will come in from, if a shoot's getting a dieback on it, it'll kill that shoot out potentially, and 99% of the time will stop at the junction against the cane. If we jump to the G9, it's a little bit of a different story with the G9. There's 82.8% of the vines that we're monitoring, so again it's 5,500 plants just on 10 orchards. The biggest difference with this, so there's a bit more shoot dieback on it, but I think the biggest thing for me was looking at it was the percentage of canes where it goes from the shoot into the cane. So it tends that it will get in and strangle out the nutrient, or flow through the fruit, and actually the fruit will start to shrivel up a bit, similar to the Hort 16A. The G3, if it gets into the cane, will tend to expand from what I've seen, and looks like nearly calycine behind it, which is a good sign. This is just that way. I only pushed it once. Here we go. So the G9, there's a couple of orchards that are younger orchards. This is one where the leaders have actually died back. So we have seen this around on the G9, where it will get through the canes or into the leader, and it'll strangle out the leader, and that leader will collapse. I haven't noticed it on a leader on the younger G3 that we've had a look at. The numbers that I've been looking at is all 2010 grafts, and there's the odd bit of 2011 where they've had 2010 and a bit of 11, so this was an 11. Does get exudate in it. Right up through here, there's little pinpricks of exudate coming out, which is an interesting one. The G3, this first photo on this side over here, was a leader that was pulled down in December last year. The photo was taken on the 11th of January, where the PSA got in from the end of the cane, come back and sort of stopped there. This was taken yesterday, and those canes that are of this point here are at the top of the string, so 3 metre long canes, so it hasn't progressed down that leader to kill it out. From my point of view as a grower, you look at, I think the challenge will be when you're growing leaders, it's a soft shoot. If you lose a leader, you lose the whole leader. Once you get the leader tied down, you get canes coming off that, you get PSA in a shoot, you'll lose a shoot, or next year's fruiting cane. So next year is going to be the challenge as a grower, to get your canopy established. Once you get past there, I think it'll be a bit easier. So the other thing we've been doing is up at Braden's place, some smart kiwis, and there's a couple other smart kiwi trials. This was one that was done at Braden's onto infected stumps. So his Hort 16A orchard that was cut back against the leader, then they grew new canes up strings. It was then cut again because of PSA above the graft. And then when I got there in December, there was still some Hort 16A that should be cut off and grafted onto suckers, Bruno suckers that were coming up. So there's a Bruno sucker on either side. The stumps were infected. Braden had tagged a fair chunk of them. This is looking down the row. What we grafted into there was Y3, Y9, G14, Hayward as a control, M91 and M56 as a couple of males. I haven't got the numbers today as the percentage of graft take, but my observation without writing it down is you'd be saying 95% of those on the Bruno suckers have taken, which is a positive sign. There's also some other monitoring that's been going on with Jane's crew, and they were orchards that have been cut off due to PSA back last year. They were grafted, and it was only G3 and G14 that have been grafted onto them, as no G9 was released last year, and so they've been monitoring those. The graft success was about 85% on those due to PSA, or we're not sure what the reason, possibly that. And the average dieback is about 1% in those. It hasn't moved much in the last monitoring round. This is talking about males. This is some plant and food information. So this is from a clonal block up at Plant and Food, so it's only one site. It's set out scientifically, it's standardised, it's randomised. It was infected in March 2011, so it's had a year of infection on there now. And it reinforces some of the comments that you hear around the place of that the Bruce is not looking so flash, and the sparkler is sitting about the same. So if you look at that, the black means that the percentage of vines that have been removed of that variety. The Bruce and the sparkler sit here, so there's only, most of it's gone. M91 is at the right end, and backs up what I've been seeing in the field is that you might get a shoot collapse on it, but it hasn't seemed to go into the cane and kill a cane or a leader out. The M33 is at that end. It's one of those M's. So the M33 and 91 are at the right end of where we're heading. This is a speed of progression. So there were a number of orchards that were started to be monitored before there was any infection in them. And it reinforces a bit about what we're seeing in the pie graphs of how it's moving. So this one is the G3 is the bottom number, G9 is the top number. I'll just make point the cane dieback, how it says cane dieback, and that we're just clarifying this morning with what they were seeing. That cane dieback is probably more like 90% of that cane dieback is actually shoot dieback. So it was just the difference in how we were looking at things. So that was being monitored from a point of view that anything that was growing off the leader pretty much was a cane. So if it was this year's fruiting canes, it was still a cane rather than a shoot, where I've been calling it a shoot. So you look at that and it's 12% was, you probably put it all down to shoot dieback, not cane dieback. So you jump to this next one. He's cut out in the G9 block, all the males have now been cut out. The orchard has Hort 16A and Hayward around the three sides of it, and one end has paddock and a big hedge. This is 1 year off the graft. So again, there's 1 point down here on the G3, and the G9 sitting up at about 50 or 60% of plants that'll have some shoot dieback on them. This is the worst orchard that we've been monitoring. There's been no protection program on it, to sort of emphasise that. The trend from what I've been looking at is that protection program has actually been working. The guys that haven't done any protection tend to be at the worst end of symptoms for the PSA on the G3, on the wider scale of things. And so in an orchard that hasn't had any protection at all, that's sort of where it sits. And so they've got 50 or 6% of cane. I've looked at it, you'd say that all of that is probably shoot dieback and not actually getting into the cane. So it's getting in and stopping. And just to summarise, to date, the G3, 9 and G14 appear to be more tolerant than the Hort 16A. We've all seen that. In terms of relative tolerance, the G14 seems to be the most, and then G3 followed by the G9. All of these varieties require some level of intervention, so they're going to need spraying. They're going to need cleaning tools between plants so you don't transfer it and continually infect other clean plants on your orchard. The inoculum load, sprays and vine management and the weather will all impact on the infection levels on these orchards. Thanks.
Thanks, Leighton. I'm going to get up here to show you a video. I'm not going to speak too much. If you were at the last meeting and as it turns out, the start of this meeting, you've seen a bit of attempted comedy. Jason Benge had a crack at a bit of comedy last time, and so we've canned him. He's not going to speak again. But I'm going to present or open the presentation of a video of the process that we're going through up on the field site up Number 2 Road, where we're doing the product testing. It's a little difficult to get everybody out and up there, and then you only see a piece of the puzzle. So instead, we've put together a video from Woe to Go of that product testing process. So I'm going to sit back down, and the guys are going to play the video.
This short video has been prepared to provide the viewers and particularly growers with a greater understanding of the KVH Zespri field testing program, which commenced in November 2011. The goal of this program is to test the efficacy of products for the control of PSAV under real-world field conditions. Field testing involves treating clean potted plants with products, followed by active inoculation with PSAV and then assessment of symptoms. A series of field trials is involved, with each lasting a minimum of 4 weeks. The field trials start with potted plants which are free of PSAV. Initially, Hort 16A plants sourced from Tauranga and Katikati in August 2011 were used. However, in January 2012, these plants, which were being kept in a nursery in Rotorua, contracted PSAV. Now plants, both Hayward and Hort 16A, propagated in Kerikeri, are being used. The images presented here are from Kerikeri. At the beginning of each trial, the potted plants are treated with different products. These are identified by the Zespri product testing team, who meet regularly to plan the field trials, taking into consideration the immediate needs of the industry and factors like product registration, usage, availability and efficacy. The products are applied by Hort evaluation. Initially this was done in Rotorua, but is now done in Hamilton. On the morning that inoculation is scheduled, the plants are transported to the trial site in Te Puke, initially from Rotorua but now from Hamilton. Upon arrival, the plants are inoculated with PSAV in a tent with approval from MAF. Fresh inoculum is provided by Plant and Food Research on the day. Following inoculation, the plants are allowed to dry before randomly positioning them in the trial block. This work is carried out by Hort Evaluation with support from Zespri and KVH. Once the plants are in place and if dry, they are watered by overhead sprinklers for 24 to 48 hours to ensure an infection period occurs. Following that, the plants are watered daily with drippers in each pot. PSA symptoms are assessed at weekly intervals following inoculation for about a month. The total amount of leaf area per plant covered in leaf spots is visually estimated each time, as well as any secondary symptoms and any phytotoxicity. At the end of each trial, the plants are removed and destroyed. This work is also carried out by Hort Evaluation. Each trial ends with the results being analysed, interpreted and reported by KVH and Zespri on the KVH website, at industry meetings and in industry publications like the Kiwifruit Journal. To date, 2 trials have been completed with another 2 trials in progress. Initially the trials were conducted on Hort 16A in Hayward, however we are planning a shift to new varieties next spring. Some of the products have shown promising results which are available on the KVH website. If you have any queries regarding the product testing program or PSA, please contact KVH.
Okay. Jace will be up at the end of the session to answer any questions that you might have about that. It is now my pleasure to invite Rob Beresford from Plant and Food Research and Michael Udstrom is going to join him, I think, after the start to talk about the disease prediction model. So, Rob, the floor is yours.
Good. Thanks very much for that, Dave, and thanks for the opportunity to come and talk to you today about this work we're doing. I'm going to be giving you some background about this disease risk prediction model that we've been developing jointly between Plant and Food Research, Zespri and KVH and NIWA. So I'm just going to give you a rundown on the background of where we've come from with the risk prediction model and a little bit about what it's going to try and prove. So it's basically an online support tool designed to help with disease management around PSA, and it's going to be available on the KVH website. It's designed to identify approaching weather systems which bring high risk of infection of PSA. Obviously, to design a model like this, we have to have some information about what constitutes high risk weather conditions, and that's some of the work I'll be telling you about today. So the model is really designed to identify low risk periods, so that you can identify periods that are safe for orchard operations, but also to identify periods when it's high risk of infection using weather forecast data, so going out for 2 to 5 days ahead particularly to plan the application of protectant sprays. So dating back to October or a bit earlier than that, September last year in 2011, we developed a preliminary risk model. We were asked by the industry to see if we could come up with a disease forecasting system for PSA, and we developed a preliminary model. It was developed at the Te Puke Research Orchard using the facilities there, particularly the weather data that was available there and some of the PSA-infected orchard blocks. I'll just tell you a little bit about conditions for bacterial infection, what we know about PSA infection. Pseudomonas diseases, and PSA and kiwifruit obviously is not the only Pseudomonas disease. They affect quite a wide range of crops, and they have particular conditions. Generally cool, wet weather conditions is what favours infection by Pseudomonas diseases. Possible reasons why it's cool temperatures: the bacteria are favoured by cooler conditions. Cold temperatures may cause some effects on the plants, cold temperature injury, which may allow infection by the bacteria. And another thing is that periods of wetness in the field, which are long enough for infection to occur, may only occur when the temperatures are cool, like in the early spring and in the autumn period. So we don't yet know the exact relationship between infection and weather conditions, wetness and temperature conditions. So to initiate this modelling exercise, we had to come up with a best guess of what the conditions might be. Now this is a graph, I'm not sure how well you can see it, but it shows along the bottom axis there, it shows temperature, and up the vertical axis there, it shows the relative rate of multiplication of bacteria. And this is the relationship we've chosen to work with our PSA model. And what we do with this relationship is we look at hourly temperature data, which is either forecast by NIWA or else recorded at weather stations in the district. We look at it hour by hour and use the temperature information to work out the level of risk on that graph. So if it's very cool, right, like down the left hand here and around 0 degrees, obviously there's not very much infection occurring. An optimum temperature around about 20 degrees, and then it drops off as temperatures go up above that. So that hourly infection risk from that model, we call it an M index multiplication, is evaluated, as I say, hourly. So the hourly temperatures generate M values. The M values, they're accumulated, excuse me, accumulated over 3-day periods. For example, today and the preceding 2 days, or it might be today and the next. Actually, I've got a glass of water here. Thanks. Thanks, Dave. That's better. So they're accumulated hourly over 3-day periods, but only during hours when there's high relative humidity. So it's the wet hours that drive this index. And I'll probably skip over this slide because it's probably too small to see, but it shows just some weather data over a period in September this year, 15th and 16th of September. It shows the M values during the periods of high risk, calculated using that relationship. So those 3-day accumulations of that hourly index are used to output a risk index we call the R index, and this is the important one that you have to remember. It's generated on days with some rainfall. We consider in our preliminary version of the model that 1 millimetre of rain per day is enough for infection by PSA. So on days when there's a millimetre or more of rainfall, the risk index generates a value. This graph here just shows you an example of the kind of risk information. These bars here are the R index values on certain days. This is an hourly temperature trace, so that's the actual hourly weather data going up and down, up in the day, down at night. The blue line along there is the rainfall. I've turned the axis upside down so that the lower those lines go, the more rainfall there is. So you can see that these are individual days here from the 1st of September to the 16th of September 2011. A couple of days or 3 days there with enough rainfall to produce an R index value. And that R index on say that day, for example, consists of the temperatures during that day, the day before that, and the day before that, and that's how the M index is used to work out the R index. So that's just a little bit of background about the way the model works. It uses temperature and humidity. So obviously, in order to use this model in any kind of a way to manage PSA, we have to define what the R index means in terms of infection risk in orchards. As I said before, obviously the R index has a maximum value of 72. That would be 3 lots of 24 hours if it was continuously high humidity for 3 days in a row. So we can take that range from 0 to 72 and divide it up into categories. And when the model is available on the website, you'll see these colours. So the main thing to focus on in this slide is really the idea of the colours rather than all the information that's in behind it. But it produces 6 risk categories, and all it does is it uses that R value and divides it up into groups of 10. 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and greater than 50. So those are our levels of risk that we've identified from the model. Now we're relying here on other disease systems in order to interpret what risk this represents, and we are using this a disease forecasting system that's been widely used around the world for fire blight in apples, and in plant and food research we've done a lot of work over the years with fire blight in apples because, of course, of getting our apples into the Australian market. So from information about fire blight, we know that the amount of infection depends on weather, but also the amount of bacterial inoculum present. And the risk is greatest in already infected orchards, so that's fairly clear. The risk is high in clean orchards neighbouring infected orchards, so that's in infected zones, and the risk is lowest in orchards in PSA-free zones. We also know, of course, that cultivar susceptibility affects PSA risk, and it was interesting to hear the talk just before on the relative performance of different cultivars. At the moment, as things stand right now, we haven't collated and assessed that data in a way where we can actually introduce that cultivar susceptibility into the model, but that's something that we will be working on over the next few months. So I'm just going to look at these different colour categories that we've got and just very briefly explain how we use the weather information and the amount of disease present to interpret the risk in the different categories. So low risk, category 1, the blue, the definition of that is that infection is unlikely, although a small amount may occur where inoculum load is high. In other words, in an already infected orchard, even at that low level of risk, there may be risk of some infection occurring. The slight risk, or the green category, a small amount of infection is likely in any orchard in an infected zone. Working up through here, slight to moderate risk, the yellow category. New infection is likely to produce an increase in disease where inoculum load is high, for example, in orchards with existing symptoms. Symptomless orchards at this level of risk probably have a slight risk. Moderate risk, new infection is likely to produce an increase in disease in any orchard in an infected zone. High risk, the red category. Substantial infection leading to disease increase is likely where inoculum load is high. And symptomless orchards have a moderate risk with that in that category. And then at the bottom there, which some of you might not be able to see because it may be hidden, is extreme risk, and that's the purple category. Substantial infection leading to a significant increase in disease is likely in any orchard in an infected zone. So that's kind of fairly sort of arbitrary and hypothetical, the way we've interpreted those risk categories. So we needed, obviously, to try and get some field verification of the model in relation to actual infection. So what does the R-index mean in terms of infection in real orchards? So we did a comparison, looked at infection arising in a PSA-infected gold kiwifruit orchard at Te Puke Research Orchard in relation to the risk index. A colleague of mine, Alistair Mackay, developed a method for exposing what we call trap plants in an orchard for week-long periods under PSA-infected gold vines. And this is what we call our trap plant method. There were weekly trap plant exposures. They were trays of 6 gold seedlings put out in 8 different positions under the vines in an orchard block. We did this for 9 weeks in a row from the beginning of September last spring through to the 3rd of November. 8 trays of 6 plants, that's right. So the trap plants were then removed from the field and put into a lab and incubated for 20 days, and then we quantitatively assessed the symptoms on them. We looked at the number of leaf spots per leaf that developed on these trap plants. So you can see that these week-long exposures isolated periods of field conditions so that we could then bring these plants away from further infection and then analyse what developed on them. So we assessed them after 20 days. Now the seedlings, we did confirm with tests for each batch of seedlings that was put out that we were indeed looking at PSAV symptoms, which was the same as were in the orchard. And I'll just get that right. I think that's the first one. So this is just showing the time period that goes from the 1st of September on the left through to the 6th of October. That's the first 5 weeks of the exposures. And you can see that this is the R index values here, and these are colour-coded according to those risk categories. It goes from 0 here up to 50 here. So there were no extreme events and no high events in that period. But you can see these are the week-long exposures, 1 to 8 September, so on through to the 6th of October, and that's first 4 groups. And it shows you the numbers of leaf spots that developed in these exposure periods. So here there was a period with no R index values. In other words, there was actually no rainfall, and there were no leaf spots. This period here had 3 days when there was rainfall and an R index value was generated. It was in this green slight category here, 13 spots per leaf, and that's the average over all those leaves that were exposed. So for these other weeks, there were 12, 11 and 29 spots per leaf. This period here, 29 September to 6 October, there was some higher risk in the moderate category, getting up to the moderate category for that particular week. And then this is the other 4 of the 9 weeks. There was a period in here when we were getting a high risk, between 40 or above in terms of the R index, and 43 spots per leaf in that one, 37 spots per leaf in this one with a number of moderate risk days. So you can see that there's looking like quite a strong relationship between our model and the amount of infection arising. When you plot those things together, if you plot this is the weekly sum of the R index derived from the high relative humidity. And this is the average number of leaf spots on those plants. Very close correlation, as you can see. This 95% of the variation in that number of leaf spots was explained by this weekly sum of the R index. So that's looking like the model is predicting something quite accurately. So we can say that the PSA risk model accurately predicted conditions for leaf infection. We can also say that rain is required for infection. We can say that with certainty. And you can see that because rain is required for infection, some infection can occur in most weeks. So that's quite clearly identifying that the levels of risk that we are facing. Now, the question arises, of course, what about cane infection? What about cultivars and other questions like that? And those are questions which we are going to be moving on to next. So I'll just briefly say that we're at Plant and Food Research in Auckland, we're actually moving on to a series of controlled environment experiments to really try and identify more accurately what the temperature and wetness requirements are for infection. And the new data will obviously be used to improve the risk model as we go along. There's a number of different field epidemiology studies that are going on at the moment, and through these we hope to gain information which will allow us to interpret how the R index relates to cane infection in different cultivars and try and get some more information around that. We could wait and try and get the ultimate answer before we go out with this model, but we believe that it's more important to actually get the tool out there and get the industry using it and becoming familiar with it, and start putting it to good use. So the model's being implemented. We're working with NIWA to implement the preliminary risk model on the KVH website for growers to access. And Michael Udstrom's going to talk now, shortly, about that implementation and the details on the forecast data that they're using. So I'd just like to finish off by acknowledging some of the colleagues that I've been working with. Alistair Mackay, who's really done the trap plant work. Kathy McKenna and Shirley Dobson here at Te Puke Research Orchard, they've run the trap plant study, and Annette Blackmore at Plant and Food and Kerry Kerry, who produced all those trap plant seedlings that we used in that study. Thanks very much.
Thank you, Rob. What Rob didn't sort of say in probably enough detail on that was that the fire blight model that he talked about that was developed for the pip fruit industry took years, I think, close to 9 or 10 years to develop. In 9 months, or maybe even less, these guys have turned around a preliminary model. Of course, it's preliminary. It'll get better and better with time, but hopefully it's a resource that you guys can use. I'm now going to ask Michael Ludstrom to come up, and he's going to tell you a little bit more about the NIWA side and the implementation. Michael.
So thanks for the opportunity to come and talk to you. I guess one of the key things that Rob was talking about is if you have valid observations, you can generate a model. And so what happens if you want to forecast into the future? And of course, and that's really what I suspect people want to know, is what's the risk going to be like in tomorrow or a few days' time. And so that will really come down to how well can we forecast the variables that in fact drive that model. So I just want to talk briefly about what we're doing in the whole weather prediction side. So I guess the forecasting system that we operate at NIWA has there's a bunch of different models, and there's some details there that you may or may not want to read. But basically, as I guess everybody knows, as we get closer to the present, our forecasts get better. And this slide just really says we can start at 15 days. We can get a certain amount of skill. Then we have access to a global model that runs at very high resolution, which gives us more skill. But when we get into within a 2-day range, we can do extremely well. And I'll show some examples of that in a moment. And I'll just talk one detail about the model that we're using, at least at the short range, which is supposed useful in terms of the forecast for PSA risk, but also for management of orchards, I suspect, for other reasons. I guess we call it the New Zealand Limited Area Model. It's based on a model that comes out of the UK Met Office. It's one of the leading environmental forecasting systems on the planet. It requires a supercomputer, so we've got 18 tonnes of it there to do that. And it makes, I guess one of the key things is it makes use of the observations that come in from satellites and ships and aircraft and drifting buoys and those sorts of things. So our focus is strongly on trying to make the forecast the most accurate they can be. Now I guess, so what does one of these things look like? This is a cloud picture taken from a satellite or a couple of satellite passes showing our model domain. Here's Eastern Australia, New Zealand. And then we have a forecast of what the cloud would look like, just the low cloudness. This is total cloud, what the low cloud would look like. And it's this, and I guess if you look at something like this cutoff low here, we're able to model these systems extremely well. And so I think we are in a place where we can actually produce useful forecasts, but I want to prove that to you. And here's an example for Te Puke for today. We show, on these particular cases, we show a forecast, which in this case is relative humidity, and the numbers for relative humidity are up around 90% here. Remember, Rob referred to 81% as being a key number. The actual observations coming in from the Te Puke almost lie perfectly on top. And I guess if I go there, you can see the observations. So at least on this one-off instance, it looks like we're able to forecast relative humidity very well. And this is a temperature forecast down here. And so let me just show you this one. And here's another example from a different orchard, but it gives you, from a different site, but it gives you the same feeling. Don't worry too much about the detail. The red line is the forecast of temperature into the future. The actual orange line there, which lies almost exactly on top of it, is the actual observations as they come in. And I guess the only point I'm putting those up there for you is to point out that these forecast models are now able to in fact make forecasts of temperature to within a degree on average, even almost all the way out to 48 hours, and likewise for relative humidity to within actual measurement units of relative humidity sensors. And I suspect some of you won't see this. Here's time along the bottom here. Here's 30 hours. The forecast accuracy of temperature wanders along up here, and before you cross 1.5 degrees, you're 30 hours into the future, and it has almost no bias. So the error in the forecast ranges from 1.1 to 1.6 degrees, and this is over 10 months of data, or 11 months of data. For relative humidity, this is the 7% error here. And again, this is time. So we can predict relative humidity to kind of 5 to 7%. And if we look at the index that Rob is particularly interested in, is how well can we forecast relative humidity 81%. This is another way of looking at it. Here's 81% as a threshold from 60% to 95%. The solid line is what's observed, the number of times this has occurred in this 11-month period, and the dotted line is the number of times we've forecasted. So basically what this is saying is the model we have is able to make a very good estimate of relative humidity and indeed of temperature, and we get similar but not quite so good results for precipitation. So what does this look like when you put all of that information and generate a risk model using Rob's model, or the model from Plant and Food, I should say? And so as it will appear on the Zespri, on the KVH website, we'll have so we have time along the bottom here in terms of days and hours of the day. There'll be 3 axes. This one is telling you how much rain we are forecasting, and so in this particular case, in this instance, just after noon, we're forecasting a very small amount of rain at Te Puke, and I guess that's today, and in fact there was a brief rainfall just before we arrived, which is perhaps not quite at the right time, but it is below the 1 millimetre threshold which is required. So this is a forecast of the temperature. We're forecasting more rain for tomorrow. This is the relative humidity forecast. That's the 81% line, and this is the risk index using Rob's colour code. So essentially no risk or very low risk through to essentially midnight tonight, and slightly elevated risk in the evening. And then there is, I guess, the other point here is that the model relies on complete days, and our forecast, so a forecast in this particular case, a 2-day forecast that starts at 6 o'clock in the morning, will finish at 6 o'clock in the morning 2 days later, or one here starting at 1800 6 p.m. will finish at 6 p.m. So it doesn't complete a whole day, and so consequently at the end of the period there is a region where we cannot make a forecast, so we'll symbolise it with something like this. Down here we have no indication of what the risk is. The risk model indicates it's 0, which was Rob's top. You can't calculate it. So that was for a 2-day forecast, and we can do the same for 6 days. It's exactly the same format. So in this particular case, for Te Puke here, the risk is blue in the first period, then it goes into yellow, and again we run out here. The risk categories are over here, from green to purple. Relative humidity is the blue line, the temperature is the red line, and here's the precipitation. So I guess all of the model inputs that Rob needs in order to calculate a risk index are also displayed, so you can look at those as well. So we can do that for sites, but we can also do it for the whole region, because we forecast the entire region. So for example, for the high resolution model, the NZLAM model, here's a forecast for the risk through to midnight on the 16th. And basically the whole of the North Island is at low risk except for this little region over here, and it's all to do with the rainfall and relative humidity, obviously. If you look at the 6-day forecast model, it's not quite so high resolution, but it's telling you the same information. These are for the same periods, and we're using the same colour bar here as was used in the site-specific forecast and Rob described. If we go out, in this particular case, out to the 19th, and out here 20th, you see the risk increases on the 19th, but it never gets above yellow. And so this is a way of giving you some indication of, when we use this model, of what it calculates for that risk into the future. And so ultimately it'll end up on the website, which presently has quite a lot of weather information. It has 2, 6 and 15-day forecasts for a number of sites. It has forecasts of spatial patterns as well, rainfall, winds and those sorts of things. And I guess this is how it looks on the actual website. So I've actually this is on the KVH website, and here's an example. And I just wanted to point out a couple of things here. So we make a forecast. At the moment, we're putting these forecasts out onto the site twice daily. So at 6 p.m. in the evening and 6 a.m. in the morning, they appear there around 11 o'clock in the morning, 11 o'clock at night. And then every hour we update them with the actual observations that are coming in from those sites. So these are forecasts for specific sites. And the reason we put the observations on there is so that you as a user of these, on the basis that weather is important, can look at the observations and see, are the observations similar to or the same as the forecast? If they're very different, then you can almost certainly distrust the forecast for the rest of the period. But if they are the same, then there's a high probability that the forecast is a very good one. So they're put there to enable you to make better decisions about whether to use the forecast or not, and also for you to be able to see how well it's doing. I guess that's it. Thank you.
Thank you, Michael. Excellent. We're going to change tack slightly. As has been typical of these meetings, they're not just the Zespri KVH program presenting its information, but this time we've got Murray Judd here to give us a Task Force Green update. So, Murray, I'll welcome you up.
Thanks, Dave. I might just move around a little. I guess I'd like to, depending how time goes, talk about perhaps 3 or 4 trials that we've done with antibiotics, with streptomycin, and a couple of other things. And we'll see how many trials we get through in about a quarter of an hour or 20 minutes. There's a whole bunch of people involved here. So it's not just me. This is also, I couldn't resist, I'm bound to say, the alliteration of Seeka on strep, but really it's Task Force Green. And so that's a cooperative venture between Seeka and EastPack. The trials that I'm going to look at, there's a couple there that you can't see, and the reason you can't see them is that I'm not going to talk about them. We're going to talk, starting with some little vines, some seedlings. Well, first up, in fact, we'll talk about a trial that we tried at the very end of last winter. Then we'll look at some mini seedlings, looking for efficacy of strep, to see how much strep might be needed to cure a vine. Then we'll look at some bigger plants, some potted plants, looking again at efficacy and a few other things, and finally some results from work with full-scale vines. Be nice if that would be good. Remember, our starting point on strep last, I don't know when, August, July, pick sometime last winter, was that, if you're like me at least, you knew very little. So I'm not claiming that everyone in the world knew as little as I did, but I knew very little. So its efficacy was unknown, how long it might work, the effect of any side effects, or the effect of timing, when we might put it on. What sort of difference will that make in the efficacy of strep? So the first trial was started, in fact, when I was overseas, but it was because of the enthusiasm for looking at antibiotics. We tried putting it on vines that were mature gold vines that were heavily infected, and we injected them before sap flow to see if we could carry the strep through the vine and what effect that might have on the infection. The vines are, we can show you pictures like this all day, but we won't. They were heavily infected. This is sort of a bit of an insult, really. This is where we injected the vine, and so the white stuff there is wax that was put on the hole, and we have red ooze coming out the very hole that we injected the strep into, which is probably not a good look, really. A bit of that as well. The outcome is that all the males just really didn't survive spring. There was poor movement of strep through the wood. We were using the lab that VLS established, so we could take wood cores and look for PSA, because this is before leaves even, when they're very little, to see if we were killing strep. And we found very poor movement, really, of strep through the vine. There was no obvious efficacy, which was a bit of a pain. We then, spring was coming along, and so, spring had sprung, we started looking at some much smaller vines, some seedlings, which I'll show you pictures of in a minute. And the aim, they were Bruno and Hayward, because that was all we had available. And the aim was to look at how much strep did you need to affect PSA, because our last experiment hadn't worked too well, and what other effects might it have on these little seedlings. We scored these seedlings very regularly. Part of the deal here is that sometimes it's hard to tell which is which between a PSA sign and phytotoxicity, and we won't dwell too much on that today, but it's an issue. We spray these little vines with concentrated PSA, and so that in itself is a little bit of an issue, and we can talk more about that at another time too. One of the things we probably need to remember is that these plants are seedlings, so we expect them to vary from plant to plant, and so you had 6 or 8 seedlings in each treatment. And unusually, remembering that the first trial that I've described, the vines died, that didn't do any good at all really. These vines generally look so good, so these are tiny little seedlings, they look so good that we re-sprayed them with PSA after a couple of weeks. And this is concentrated PSA, but we wanted to give them a harder test really. That's quite unlike what happened in the subsequent experiments. It's got bored with my talk already. Right. Just to give you an idea of what these seedlings look like, so they're 4 or 5 leaves. We might try another one like that. You can see that there's some spotting on some vines, some plants, but generally that plant looks pretty good. I'm probably pushing a wrong button. We were keeping these in a very humid environment. One of the things we learnt last year is that PSA really likes water to spread, and so you can see here the water on the leaves. We kept them in a high humidity enclosure. All right, too quick. That's the sort of overall look of the little seedlings at the end of the trial. So they were still looking remarkably good, and you can see some spotting and things, but they hadn't all turned to ooze or collapsed. Let's look at the results, and I'm only looking at a few things, so again, this is not supposed to be an eye test. Basically, as we move from left to right, the level of strep in the plant should have increased. The reason I say should have is that these plants were actually given strep to take up before the trial started, and so we weren't exactly sure how much they'd taken up, and we waited till the end of the experiment to actually check for residues in the leaves and see how much, and that worked reasonably well. So from left to right, more strep was put in, we hoped, into the seedling. On the right-hand side, you see how the infection went on the trial on the plants that had no strep at all. And you can see going up was a bad thing in this graph. So those vines became very rapidly infected along there. These ones, you can see, these ones are much, much lower, and they're the highest strep levels. And as we come back, about here, they're pretty much the same. This is a bit of an odd one, isn't it? And so we checked its leaf level for strep, and in fact found that it was not according to sequence. Along the bottom here, this is a nominal treatment level going from 10 ppm, which is quite low, to 5,000, which is outrageously high. And the odd one out is this one here. You can see this guy who had apparently less strep had 1.2 in his leaves at the end. This one only had half that, and clearly it didn't work too well. So one of the useful things that we can say from this is that a strep level of around 1 or 2 ppm seemed to work pretty well. Up along here, we were up at 60 as opposed to 2, and nothing much had happened. And up along here, we were up at 860. 800, that is, as opposed to 1, and certainly it worked better, but there are some other issues there which we'll come to in later experiments. So this was pretty useful in the sense of at least giving a ballpark where the vines still looked good and we had reasonable efficacy against PSA. We have the same thing with Hayward, and again, interestingly, but in a different place, we had an odd one out, and again, when we analysed the leaves, it was out of sequence in terms of its concentration. If we heap all those together, and don't panic, I'm not going to give you a test on this afterwards, the ones on the top we've already ruled out as being too low, the ones of of less than 1. If we look at these others, what do we learn? One thing we learn is that it was quite long-lasting. At this point, the trial started here. These are weeks along the bottom. After 2.5 weeks, we re-sprayed with PSA. And you can see in some instances, think of this blue one, it increased the symptoms a little. But they were still going pretty well right up to the end, which is 6 weeks later. So in this case, in a reasonable environment, in certainly a human environment, but in very small plants that might behave differently from mature plants, we had reasonably long-lasting results. What do we learn? Generally, these plants look good. Mostly they looked like in the first trial, most of our vines, and they don't look good. These ones look good. We had efficacy at around 1 to 2 ppm, and it lasted for quite a long while. But remember, these are small plants. They don't have flowers. They don't have fruit. They're not trying to make a whole lot of new shoots, and they vary a little more because they're not clonal. Let's go to one step bigger. Potted plants outside, a similar ilk to the movie we saw from KVH with Jason. They were scored a couple of times a week, and some of you have seen these results because I seem to have been talking with lamentable frequency recently. But let's see how they go. These plants again were prepared. They were Brunos in this case. They were sprayed with strep, and then subsequently the next day sprayed with PSA, concentrated PSA again. This is the overall look of the data, and again we'll go to some more detail, so don't panic if you can't see that. The experiment, oh, that was frighteningly quick even for me. We'll perhaps go back to it. In fact, we'll go back one more. The experiment lasts quite a while. Again, each of the dates here is a week. There's one missing just because I can't fit it in. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and probably in the end, with a little gap in the middle that I'll talk about. For those of you who have seen this sort of data from me before, the blue line is what we thought were the PSA symptoms, and you can see these ones on the end. Now, I do keep pushing the wrong button. It's only me, no one else to blame. The blue line is the PSA symptoms. This has no protection and no PSA applied. This one had no protection but did have PSA applied. So this should be the fastest PSA symptom, and it was. And it went up highest. The maximum here is, what's the scale? 5. So it's pretty close to 5 if you can read that, but don't worry if you can't. This is the negative one, which shows that in this environment there was quite a lot of PSA around apart from us spraying it, because we didn't spray it in the same place as we put the plants, so that the neg went up pretty fast. The gap here is because the trial, we carried it on so long, is that at this point it was getting very difficult because new leaves were growing from these little plants if they hadn't died. And so at this point, for interest really, we started scoring only the new leaves and not the old leaves, because nothing had been sprayed on the new leaves. They had emerged subsequent to the treatments being applied. And we'll look at that a little bit. The general trend that you can see here, I'll try and push the right button first time for a change. The general trend is that as the strep level was increased, the blue line gets lower and flatter, at least the first part of it does, so we got less and less PSA in the vines. It's interesting around here, isn't it? What happens here is that these are the leaves that have been sprayed with strep. These ones are new leaves that hadn't, and so we get this quite big step when we changed our scoring system, but it all makes sense. These ones that were already pretty heavily infected, like the ones beforehand, showed almost no difference because the strep hadn't been stopping the infection, and so it just carried right on. The red things are a little bit of a worry. I haven't talked about the red line, not in this talk yet anyway. The red line, the dotted red line here, is giving an indication of other things going wrong with leaves, and finally we'll let this guy come back up. This is on this treatment, which is a high strep treatment, and we had this sort of necrosis around the edge, which we had seen in many orchards in Te Puke around October, November, you might remember. And there was a question certainly at the time, whether that should be regarded as a PSA symptom, because it was nothing like we'd seen last year. There's no little small sharp-edged necrotic spots with gold red with yellow halos. And so there's some question about whether the red lines were sometimes in fact PSA or whether they were another effect, and we'll talk more about that. Okay. Moving along, the grey lines here are controls, so don't panic about them too much. Again, we're interested in efficacy and how long it lasts. This was all these ones down here they showed good efficacy, and they lasted a surprising number of weeks. We've talked about that. So what do we conclude so far? We conclude that the PSA, they worked quite well, at least some of the treatments. That on a leaf necrosis, that red thing, at low strep, the leaves were okay for that score, but at high strep, they weren't. And I haven't yet talked about leaf or plant condition, which I will do. We've talked about that leaf. There's also leaves like that, which are not incredibly pretty. And there's also plants like that, which are not only not incredibly pretty, they're downright ugly. I don't think any of us would want a plant that looked like that, but there's no necrosis, there's no small spots, so there's no sign of PSA, there's no big ugly blotches like on that first one, but the plant is clearly still very sick. It hadn't done anything, and in particular, that's the extent of growth, and I'll look at that more in a minute. Let's have a look at that, in fact. The extension of a regular plant in these trials, because they lasted a bunch of weeks, looked something like that. So it had grew up just as you'd expect for a young Bruno plant. On the highest, a number of them, strep levels, what we found was that the internodes were just amazingly short. So that while there was no strep things, we ended up with vines that we wouldn't want in our orchards. They were stunted, they were dwarfed. And I'll come back to that later because we're about to move because I'm under time constraint. Are you still happy, Dave? I can stop, you see, whenever he wants me to. All right? So what are we learning? We're learning from this experiment that it worked for PSA. It had lasted a long time. Symptoms reduced with increasing strep, but at the same time as symptoms reducing, the nasty side effects developed increasingly, including shoot growth being retarded. So the block had a few, so we're talking a number like 6 in a hectare block that had symptoms of PSA. So it wasn't a wildly infected block, but it had some that had been cut out and weren't included in the trial, basically. They were scored weekly. As many growers were doing, or sometimes doing, vines with secondary symptoms were cut out as they were seen. And so we need to keep that in mind as we talk about our scoring system. And of course, because it was on an orchard, there was no applied PSA. We didn't go around spraying it sort of willy-nilly. Right. This graph shows along the bottom, they're about monthly things. The little ones are weeks, just so you sort of get your time scale right. The blue lines here are males, and the green lines are females, blue for boys and green for girls. And the dotted lines are controls, so they were vines that were not injected. These are now injections. And the solid lines are the treatments. So what we find, if we look at males to start with, and gold males, as we all know, are more prone to PSA than females, they stay pretty much the same for a long time, a disconcertingly long time. So this is 1 month, 2 months. You've got to say the two blue lines are still on top of each other. Then they separate in a half-hearted sort of a way, and for a while there, the control does worse, which, so what we're saying is the strep had a bit of an effect, but bugger all. And then at the end, you'd be holding your breath to say there was any long effect. If we look at females, which of course is 90% of the block by number, nothing again happened for 2 months. A little bit of a separation. Again, the control high, which is sort of nice, but not convincing. So an interestingly poor result, I would say. This is a little different, and I think we won't worry about it. We'll look a little bit at the spread of this, because this is a little bit of fun for a couple of minutes. This is a picture of the block It's on its side because I decided at the last minute, which was about 45 minutes ago, that it would fit on the screen better. These are graded by colour according to how they were last scored, and so green is good, and the redder they get, the nastier they get, and the black ones had already been cut out, that's why they're black. As they change, that's the 4th of November. If we change, that's the 8th of November, and don't panic, there's nothing I want you to see different. And then go to the next one. So that's the 17th of November, and if you are incredibly alert, and I'll go back just in case you missed it, you can see that the orangey, yellowy squares increased quite a lot, and particularly I want you to look down in that region. So suddenly we've seen a whole lot of, it's just a blob I've put on the screen, it's just across the orchard, but you can see there's a whole lot of infection in that area that's orange. What happens when the manager gets his hands on it? It all goes away. So he did an excellent job of cutting out the infection. And so the next time we measured that area, there's nothing much there. Let's look again. That's going forwards, not backwards. So what we see is that in that same area, there's now a whole bunch more infection, and there's infection here and here and here and here that was never there before. And if we do one more cycle, we're not going to do this all night, and it's gone again. What we might conclude from that is the cutting is not extensive enough. The people are manicuring the vines, cutting out the symptoms that they see. The reality is it's spreading immediately but hadn't shown symptoms in the adjacent foliage. Alrighty. All right. I think we've talked about all those things. The bottom line in terms of strep is that it was pretty poor, I would say. Not incredibly effective. Oh, it's all right. I'm not going to go through this in too tedious a detail because Dave's sort of looking twitchy. Another trial on mature vines. There's another 2 trials really, but we'll just move along. We looked at different methods of applying the strep, of putting it into a vine. We looked at different chemical products and formulations, and some of them had slightly different versions of strep. So some have a chloride, some have a dihydro, and there's another antibiotic as well called oxytetrachloride, as well as streptomycin. Again, this is outside on a real orchard, so there's no applied PSA, and the regular orchard activities, the same as the last one, there was cutting going on if secondaries were found. This orchard, I should make a note, up here, it had some secondaries at the start, but not many, but we found, soon after we started the trial, that actually symptoms move pretty rapidly in this orchard. Yeah, that's a little blur, isn't it? This is looking at the different strep and strep formulations that we used, and I think with a bit of luck the next one might be a bit clearer. It is. This is looking at you can see down here, different streps from different manufacturers and some slightly different properties. Independent of the properties, we had put the same amount of active ingredient on, independent of which guy we bought it from, at least we tried to. The control is the black line, and you can see that most of them are pathetic. Most of these are worse than the back line. In this case, we're wanting, this is level of not showing infection, just to keep you alert. So a brilliant result would be something that stayed up there the whole time. A bad result in this graph is something that drops down faster than that black line, because that black line had no strep applied at all. It was a control. You can see for, again, an unfortunate length of time. These, again, are months, roughly, 1, 2, 3. Most of these are worse than the control. At the very end, there's a little bit of a funny effect, but to be honest, we can learn a little more than that. The combination of strep plus oxy was better than strep, so the 2 antibiotics, which behave in slightly different ways, were better than one. But the overall big result surely is that, gosh, would I bother? And the answer would be no. The fact that we see some effects way out here, I am nervous of personally. I think it's too far away from the application time to be at all confident that we were really causing that issue, that result. That one is looking at different methods of application. We used a high pressure injection, we used a slow release capsule, We used spray application and we used spring-loaded syringes. If you're interested here is what line this one is, because the colours aren't too distinct, that at least crossed the control halfway along, it's actually, the spray application. Again, the same effect at the end here, but my same reservations about the result. We looked at the level here, single dose and a double dose, and while the double dose, the red one, performed better than the single, again, neither were very flash relative to the control. The blue is the control, the red is the double dose, and yes, it did better, but ho-hum. I'm not going to bother about that, I think. We talked about this slide earlier, about growth on small plants, and so we should talk about growth on big plants. This is a shoot on a big plant, a gold plant, a mature gold plant. And again, I would hope that those of you who are used to looking at gold would be surprised at the short internodes that had developed on these vines that were injected with strep. I would say not a good look, really. Hard to get a cane if it has nodes like this that fill your canopy. The other observation that again was all a surprise, we didn't do this deliberately, one might add, is that this was again on a gold orchard, again injected early. And there's two things I think that it's reasonably easy to see on this picture. One is that given that it's gold, there's a pretty low level of fruit per square metre. There's no big ropes of fruit, there's bugger all there. And the other thing is a frightening number of fruit that are this sort of size or shape. You can probably see shape easier than size in this sort of picture. So what we're saying is that the strep not only affected shoot elongation, but it also affected fruit growth. And we have done work with residues that I'm not particularly reporting on today, but where we looked at the smaller fruit, they also had a higher strep concentration in them. And I know there's a cause and effect thing there, but it's indicative. And so I think I've talked to you about all those things. And I've got one more slide because I told Dave that I'd say conclusions and then I'd say last things, and I did. So where are we? I think in all our trials at the moment, an overriding thing we have to bear in mind is that we remain uncertain as to the influence of timing. You know, we've had one season at doing these sorts of experiments. And so how much is the effect of doing it, even in terms of a mature plant, relative to flowering? If we put it on just before flowering, is the plant doing something different from putting it on 3 months later? So these experiments are all one-offs, and that has to, as a scientist, raise a few nervous thoughts in our minds. In terms of injection of strep, while it's probably environmentally sound because we're not flinging it into the atmosphere, I don't think it's produced satisfactory results. And the reason there, which I haven't particularly emphasised in today's talk, but I will now, is that I think it's very sticky. I think it gets into a vine, and I think it's a consistent theme through all the larger experiments that we've done, not so much on the tiny seedlings, but on the rest. And I think that's due to the way that we put the strep in, that it gets somewhere in a vine and then stops. So if it happens to go, if you've injected into the plumbing in some way, into a pipe, and part of that pipe ends up at a fruit, that's where it stops. And if it doesn't get to the fruit too along, then it doesn't get there. It doesn't keep moving evenly through the plant. So the fruit where it arrives ends up small, and the fruit too along ends up big. The shoot where it ends up with a reduced growth rate, and the shoot next door doesn't. So I think it's very sticky, which is a bad thing for us because we simply don't get coverage. And I think I've said all that now. That's it. Thank you. I'll leave that too.
Good on you. Thank you. Thanks, Murray. I would just want to reiterate, a lot of that work was injection. If you didn't pick up on that, there were mentions occasionally on sprays, but a lot of that work was injection, and I'm sure there'll be some more questions about that later. I'm going to talk to you briefly about measuring residues with streptomycin treatments. I'm going to talk a little bit about resistance monitoring as well, because it is a part of our program that we are monitoring streptomycin and copper resistance. And then just before we go to the questions, I want to just reiterate a few of the principles around the policy on streptomycin. Many of you, or in fact probably all of you, have received a letter from Lane this week, and I just want to reiterate a couple of those principles. You might have a few questions on that a little later on. So residue testing, I'm going to talk about a couple of trials. The first stuff is work done in Korea. This was applications to fruiting vines. It was both injection and foliar applications. There was only one treatment per vine at one time. It was replicated on 6 to 10 vines depending on the experiment that we were undertaking, and those samples of fruit and leaves were sent back to New Zealand for residue analysis at an authorised New Zealand laboratory. So for the fruit residues, what you can see in days after treatment, and bear in mind that 150 days after treatment is a post-commercial harvest capture of fruit or leaves. In this case fruit, we still have residues throughout the vine. Probably a little bit of that noise that Murray talks about as well. It's sticky, it goes some places throughout the vines. It's not necessarily always consistent, but one of the other things that this tells you is, other than the control, which of course shouldn't have any streptomycin and doesn't, the blue line at the bottom, the way that you put it in, it still ends up being there. It doesn't dissipate, it doesn't disappear, it still stays around. We could make an analogy, but it's not appropriate to do so. With fruit residues following foliar application, the numbers are generally a little lower, and yes, they do dissipate, but they don't dissipate completely. Some of that will be breakdown with UV, but you can still see levels of streptomycin found in fruit from foliar applications. Bearing in mind this is foliar applications to fruit or to fruitlets on the vine. This is not associated with a regular practice as we were having here or expected to have here in New Zealand. So this was intentionally done to try to understand what our levels of residue risk would be, and I think they clearly show you that we have some. We also did some injection trials of our own under an ACVM trial approval. We had one treatment per vine. It was done on the 22nd of October, so you can imagine this is on Hort 16A. It was pre-flowering. All the fruit are going to be destroyed from this trial as part of our approval. That's what we have to do. We'll do that at harvest. We've taken regular samples, not lots of them because it's very expensive to get lots of residue samples done, but we've taken a number of them, and so I've got some results for you. First of all, I'm going to show you leaves. I hope you can see that. Looking down the treatment column for 9, 74 and 124 days after the treatment on the 22nd of October. Obviously all of the controls have no streptomycin, that's what we wanted to see. But you can see the level of streptomycin dropping away in mature leaves, or in mature leaves from injection. When we go to the fruit, we didn't have a 9-day treatment. Of course, the fruitlets were still forming, it's fair to say, if they were even forming. But 74 and 124 days out, we had fruitlets or fruit. And as you can see, whilst the numbers are not as high as they were in the first treatment of mature leaves, they are there, and they're like the work we've seen in Korea, don't seem to be dropping much. In fact, if anything, gone up very slightly, understanding that, of course, you've got sample variances between fruit on vines, and also, as Murray has said, it's not particularly easy to track or to predict where streptomycin will go once you inject it in a vine. It doesn't necessarily go evenly throughout the vine. I said I'd tell you about resistance monitoring. We've done this a couple of times as part of our the request for ACVM when streptomycin or Key Strepto was approved for use, to ensure that we're not getting resistance build up out in the population out there. We're also looking at copper resistance. Just while we were there, we felt that that was a good idea. We've taken samples of PSA from orchards that have had authorised use of streptomycin, so of course you go where people have used it so that you can check that there's no resistance in that population. We included 18 orchards. Samples were taken pre and post-application. We've tested them for resistance both in December and February, and I can report to you that so far we have not found any resistance in any one of those samples. There's little point in continuing to take those samples right now, because if we couldn't find resistance now, we won't find it in another few months. We're not using streptomycin at the moment, but if we go back to using streptomycin in the future, this program will kick back into action and continue to monitor for that resistance. Copper resistance, on the other hand, there is copper use, and so I'm picking that we will continue to monitor copper resistance, but as I say, so far there hasn't been any seen in PSA strains out in orchards. I just want to also say, before I get started on the streptomycin residue policy stuff, that I'm sure you're all well aware that right now, Keystrepto, the approved formulation of streptomycin that was available to the industry in spring last year, is now no longer available for use. The approval was only through to, at the latest point, the 1st of December last year, or if you're using on fruiting vines, 10 or 7 days prior to any flowers opening in that orchard. So it is now not available for use. We have a nil residue policy, and that it had to be used in accordance with MAF's approvals. You've heard us talk about testing all orchards for streptomycin residues, and we'll be doing more than 9,000 tests, having started a few weeks ago and going right throughout the harvest. We've encountered a small number of positive residues in the tests that we've already done, and we believe that they are likely to be associated with unauthorised use. At the moment, we have not contacted the growers whose orchards they may have come from, because the declaration process does allow those growers to come forward, and we're giving them a fair opportunity to do so. Of course, ensuring that they're not going ahead and making significant decisions such as harvest before they're told. So where there's been use outside of the approved window or via injection or at high rates, we believe that there is a high risk of fruit residue. You've seen some of the data that I've just presented to you. If you've done that, if you're sitting in this room, we encourage you to disclose. That's what the letter says. We want to work with you. If you've done it on parts of your orchard, then we want to be able to segregate those vines that have been treated and remove that fruit from having any possibility of getting into the inventory, the export inventory. We've spent a lot of time talking to MAF. They have a regulation called the ACVM Act that outlines fairly clearly what can and can't be done. They're going to take into account all relevant factors, including the actions of growers coming forward to voluntarily declare their actions. And so the likely outcome, and we can only use those sorts of words, I'm not a MAF representative, but they've approved what I'm saying, are likely to result in remedial actions short of prosecution. But where there is no voluntary disclosure, where somebody does not put their hand up and downstream we find a residue, either as part of our residue test or, heaven forbid, as part of the offshore monitoring program by ourselves or our customers, they reserve the right to take a fairly hardline approach. And if you want to go and read the detail of what they can do, that is in the ACVM Act, and you can get that on their website. As I'm sure you all well appreciate, residues detected in exports of New Zealand kiwi fruit could have a fairly devastating consequence for all of us. Market closure, customer backlash, consumer backlash, all of those are possibilities. So the process, as you probably all well aware, there was declarations posted late last week. We would like to get as many as possible back in by the 23rd of March, or if you're in line for harvest before then, you should get them in before harvest, so it's whichever of those comes first. If you're not sure of your position, ring Zespri. Gail Carter will take your call, or David Stephen. Discuss your situation before you decide how you want to fill out that form. So that's me. I now would like to invite all the speakers to come back up to the stage to answer questions. I'm also going to ask Mike Steele to come up and Jason Benge, whose video we showed a little earlier. Rob Beresford's going to have to leave very shortly. So after Leighton has had a little plea, because he's got a request of all of you before any of you leave, I'm going to ask the first questions, if they could be, for Rob so that he can escape to catch a plane. So guys, come on up. Leighton, you're first.
One of the things that I've been looking at early in December, and when Hort 16A orchards were getting cut out, was if any orchards were riddled with PSA, but one or two vines might be standing out as being clear. If during your harvesting process or something like that, and you've got a Hort 16A orchard that is fairly riddled with PSA, I'm looking for like 1 to 10 sort of vines in an orchard that still look clean with no secondary symptoms. Tag those vines, get hold of KVH or get hold of myself, so that we can then, if they're inferring some sort of resistance, we want to know about them to move that process along and keep watching it. Cool.
So the floor is open. First questions, if we can, around the disease prediction model, and in particular maybe Rob Beresford's piece, and then we'll open Slather. He's got about 5 minutes, so I'd like to maximise the opportunity to talk to him. Jenny.
I wanted to ask Rob, we're coming into autumn, we've got low night temperatures, quite a lot of dew in the morning. Is that taken into calculations in your model?
Yeah, very good question. At this stage, of course, the model purely reacts to temperature and humidity conditions. So, no, it doesn't have anything explicit built in for the seasonality of the season around the crop and that kind of thing. And this is the information that we need to gather over the next period of research. Is how the model output needs to be interpreted in terms of seasonal risk. Although I will say that at this stage there seems to be very little to suggest that PSA ever sleeps. So as far as we know at the moment, the risk is there when the weather conditions are there.
Thanks, Rob. And the other thing to note on that prediction model is that you'll note that it doesn't distinguish if there is PSA in a region or not. You saw the risk showing up in the Waikato, for example, and currently, other than Waihi, which somebody has picked out in the paper today, is in the Waikato, and stated that now we have PSA in the Waikato. It's not over in Raglan, but the model doesn't distinguish whether or not PSA is in a region or not. It's not for these guys to decide whether or not PSA is or isn't there. It's a tool that you guys can use, and none of us can guarantee that it isn't actually in some of those other regions. Another question for Rob. If I don't see some hands fire up, yep, there's one over here.
Yeah, further to the last question regarding spray irrigation underneath vines, what influence would that have, if any?
Was that, did you say sprinkler irrigation? Yeah. Yeah, it's a bit of an unknown. In principle, any water splash will splash the PSA bacteria around, and we do know from some of the work that's been done that plant debris on the ground and even in the soil contains the PSA bacteria, and they can survive in plant debris on the ground. So yeah, under tree sprinklers would be a potential problem. We haven't got any definite data on it, but yeah, sounds like a problem to me.
Off the hook. Thank you very much, Rob. Open Slava questions now. No, come on. You can't be the only one you wanted to ask questions of. If there are no hands going in the air, then we'll wrap this up fairly quickly. Oh, okay. Good on you, Russell. I think I planted one with you. Just wait for the microphone, mate. They're recording it at the back.
What is the latest thinking, please, on how long, just relating to that last answer, how long PSA does live on ground litter and debris and in hedgerows?
Greg, are you in the audience? There he is. You might have to grab the microphone, mate, so they can record the answer. Greg Clark's going to answer that one for you. It's not associated with it.
So I think on the leaf material and decaying leaf material, we had it out to about 14 weeks. So it's quite a significant period. Cane material was similar as well, decaying, breaking down cane material. So it can last for quite a significant time on decaying material. On hedgerows and that sort of thing, I think you asked as well. It doesn't last very long on that. It seems to be, yes, it will, could be, we inoculated onto representative plants, and yes, it survived on there for a number of days, but it was always in a relative decline. And after some period, I think it was a couple of weeks, we failed to find it on there. But yes, and leaf debris that's coming off an infected vine, you will find it in there for a significant amount of time.
Okay. Thanks, Greg. That was like pulling teeth getting that question, so we'll look around the room. I can't see too much else. You guys have all got off pretty much scot-free. The guys will all be hanging around for a little while afterwards. Thank you all very, very much for coming. It's been informative, I hope, for you. Has been for me. If you don't mind, we'll clap hands to thank the speakers. We'll see you again in 6 to 8 weeks. We realise that there's a little bit of activity going to happen over the next little while, and you'll be otherwise focused on that. So we'll try not to come back and disturb you until harvest is out of the way. Thank you all.